Hello all. Bicycling has been a popular activity in urban areas over the years, and since the early 1970s, the bicycling industry has experienced what we call a bike boom. In addition to that, e-bikes started gaining attention a few years ago and have since exploded in popularity owing to its versatility. Furthermore, the notion of bike sharing is becoming increasingly popular, with companies like Uber and Lyft having their own bike share systems. So, we are going to present our project that explores the data from a bike sharing platform in the city of Richmond. We have 9 months of GPS data of trips taken by bikers in the city of Richmond. The data contains information about two kinds of bikes. One is the normal or traditional pedal bike, and the other is an electric bike, which we will be referring to as pedelec. Particularly, this new form of e-bikes are getting increasingly popular nowadays. So here are the high-level tasks and user questions we intend to answer. Our main objective is to connect the geospatial data to the temporal data to gain an understanding into the biking patterns. For example, we want to visualize the monthly usage statistics of the bikes. Since there are two types of bikes, we want to compare the usages between the bike types. In addition to that, we intend to seek insights into the time of the day when pedalers are likely to ride. Since bike sharing system has several biking stations that are spread throughout the city, we can look into their associated activity levels. Furthermore, it is important which roads and routes are being used so that infrastructural changes can be made to such routes and roads if needed. We could also explore other interesting aspects of the dataset such as duration, distance, and costs that are associated with the trips. Based on the high-level objectives we have, we targeted three use cases for our visualization. First, we visualized the aggregated monthly usage and associated station activities. Then we worked on finding insights into the correlations between several aspects of the data. For the third task, we analyzed the routes and roads of the city used by the bikers. So let's go over to the demo of the visualization tasks that we have completed. So here we see the temporal visualization of the rides taken by bikers over the period of 9 months. The overall monthly pattern is evident with bikes more frequently used in months from May to September, and the winter months see the least biking activity compared to others. Another interesting takeaway from the visualization is that irrespective of the months, the e-bikes always exceed the normal bikes in terms of ride counts. Also, winter months also see a lot of e-bike activity compared to the bike activity. Hovering over the months bar, it gives us insight into which hours of the day are particularly popular on a monthly basis. So it comes as no surprise that the summer months see a lot of biking activity at night, whereas the winter months see a lot of daytime activity. Another no surprise fact that we can see from the usages of bikes and e-bikes is that they spike at more or less the same times of the day. And hovering over months also gives us insight about the activity levels in several stations of the city. Monroe Park, Kenilworth, and Browns Island are among the most popular biking stations. So here we have the visualization to explore the various attributes of the trips. From an overall glance at the data, the pedelec people have covered more distance than normal bikes, as you can see from the data. A logarithmic scale has been used for the better understanding of the distribution of the data. With the goal of understanding the routes associated with the trips, the routes are interactively plotted when we hover over the bubbles. So as you can see, so if GPS data is available, so you can see that the routes are plotted. Okay. So some interesting aspects of the data is that there are several trips where the biker hasn't traveled much, but the duration of the trip is much higher than anticipated. For example, if we go through this, we see that this might be the reason that they have unlocked the bikes for a long time, that the biker came back to the same place after traveling. That could also have happened. So another aspect of the visualization is brushing on duration and distance extent. So as we move the brush over the data, we see that there are like several polylines that are color encoded. So we can see whether we can see how the maps what are the routes taken by pedelec and bikes based on the selection. This visualization explores the routes taken by bikers from specified stations. The data can be filtered based on the starting and ending locations, bike types, and months. So here we can see some interesting patterns based on like the filters. So for example, if we select Pleasant Park, Oregon Hill, and Pleasant Park, Oregon Hill as the ending location, then we can see the overall distribution of the GPS locations and the distance and the routes taken by the bikers. So here we can see. So this is the overall distribution. And another thing is that all the associated trips with the filters are plotted in the bubble chart as well, that displays the trips upon hover. So this is it. Thank you.